I'd like to thank the Economic Times, Rajasthan government, and other partners for inviting me to join you today to talk about the next generation mobility and transportation services. So you heard from honorable dignitaries about the challenges and the need for digital transformation in the urban mobility. Now, this is an exciting time to be in the transportation industry. There are so many opportunities for us with new funding coming in, new and existing challenges, and so much innovation happening in this space. So what I'd like to do is to step back and think about the concept of data to delivery. So what does delivery mean? It could mean a lot of different things. It could mean delivering infrastructure projects. It could mean delivering safer and time travel experiences. It could mean delivering timely and relevant information to maintenance departments, traffic operations teams. It could also mean finding new ways to connect people to the opportunities, and especially those who have been left behind. It could also mean connecting with each other and also mean growing our skills and experiences for the challenges that are coming next. So when we look at the data being generated worldwide, the overwhelming response has been there is too much of data. We can't really handle it all. So think about, there will be about 30.9 billion IoT devices that will be online by 2025. 180 zettabytes, that's 180 billion terabytes of data. And of unstructured data, which includes data from the sensors that people install specifically to get data, less than 1% is used in any form. And less than 50% of the unstructured data, typically data that was generated specifically with decision-making in mind, is used to make decisions. So what is the mission of Google? It's really organizing the world's information and making it universally accessible and useful. Now that may sound simple, but behind the scene there is a lot of complexity. We are sensing the world around us, bringing together a lot of information and data using technologies such as cloud computing, machine learning, IoT, and various others. All of these technologies enable these experiences for us as users to make it simple and easy. So we think about this in the mindset that we operate with. We call that as a 10x mindset. Really thinking what challenges are there and how do we make ourselves approach them in bigger ways. Google and its parent company Alphabet are active in a number of industries, including transportation, inventing and pioneering the use of cutting-edge technologies to solve world's biggest problem. So most people know of us as a search engine. So when we think about things that we do as a company, you might think about search or Google Assistant. Now these things is what we use as consumers. These tools that enable us to access the information about the world. As consumers, we don't think about the technology and all that is happening behind the scene. We just think about what do we need in a very simple way and deliver that information to us that is relevant. So, Google has been an innovator in transportation. For many years, we are bringing the innovation and addressing the problems of transportation, navigation, mobility, and community spaces. So when you think about the world of travelers, we are really transforming the travelers' experiences from the travel perspective. So you can think about using Google Maps or Waze on mobile devices in your car for directions. And then the next generation of technology that we are coming out with, which is the Google self-driving vehicle called Waymo. So when you think about these different technologies, what is common about them is that they are all data-driven and software-enabled experiences. And that is the transformation that is happening in the transportation sector as well. We are delivering these experiences and transforming what the travelers are able to access, understand, and make choices about. So a lot of focus has been on the commuters and the consumer travelers. So all of these technologies that we have been building with the technologies for our own products, we are now taking those and making it much more accessible through our cloud computing technologies and machine learning, and all of these technologies that we've been able to build our products with. Google Cloud Platform is a suite of cloud computing services, from computing and hosting to machine learning, that runs on the same infrastructure that all the Google products that you're very familiar with, such as Google Search, Google Maps, YouTube. We've brought all of those technologies out into a Google Cloud Platform, and so we are really looking now as to how do we help the transport departments to use their data and other public data to transform experiences. And not just for the travelers, but for those who are operating the mobility services, who are managing infrastructures. Bringing all that information in a way that is simple, easy to understand, and get you relevant information to be able to make decision. And that decision could be a planning decision, it could be operational decisions, and get the insights that help you all make decisions for your day-to-day job. So what we are doing today is really, what I'm going to talk is really about that side of it, and bringing these tools and technologies to you who are managing and operating the infrastructures and the mobility services. So in the transportation sector, our priorities today, and as we architect the future of mobility, is to provide solutions, first, to enable travelers to be connected and informed. Second, enable operations teams to make data-driven decisions using an integrated data management platform. Third is to empower teams with easy-to-use tools to build solutions faster using their existing data and IT systems. And last but not the least, empower open and enabled ecosystem that can collaborate seamlessly. Now, in order to do all of those things that I just talked about, we really need a next-gen mobility platform with the approach for configurable core modules that can be applied to many use cases. Some of the modules are geo-based asset identification. That could actually help you to identify and classify infrastructure and conditions using machine learning that could be at the edge, it could be on-prem or on the cloud, using different kinds of data that we are already generating, whether it is the videos, photos from the cameras, data from different sensors. It could be traffic signs, sensors on the bridges, roads, potholes. And all of this needs to be built into a platform using a modernized, open and secure application platform. The second module is the real-time data hub. What that lets you do is to ingest all the data, process and publish real-time and historical data. It enables you to integrate with the new and existing data sources. That could be a traffic data, it could be weather, infrastructure data, or a ridership data as well. And it also lets you publish your data to other systems. That could be an intelligent transportation system. It could be a public-facing website. It could be a data analytics platform. And the advanced analytics platform module would actually provide data warehousing capabilities to really consolidate multiple times of real-time and historical transportation data. It would enable you to sort of integrate with the visualization, open data sharing platform, allows you to build machine learning developments, training and deployment of our predictive insights. And then you could have a custom module that could be very specific to a department for data integration, specific needs for data assets, metrics, or ML models. Sorry, there's a bit of a lag. There we go. So these are some modules. These modules can really be applied across the many themes of use cases. It could be asset tracking and optimization. It could be predictive maintenance of the public buses. It could be a data-driven route planning. Instead of having a static route plans that we are doing today, maybe we could leverage the data to bring about insights of where the traffic is. It could be incident response and coordination. It could be a safety analysis. So what I'm going to do now is to go through some quick examples to start some ideas and thoughts about what could we use the data for and the technology for. So the first example is from Iowa State Transport Department. And the way they use their data to make some policies, to make some interventions from their operations in managing the congestions on the road. May I request to roll out the video, please?
10 to 12 miles to get to school. As a school superintendent, my is making sure that we get everybody to and from school safely.
Normally we get up about 4:30 and we go out and scan the roads. Matt usually goes one direction, I go the opposite.
As the road conditions change, it's important for us to stay on top of knowing what's happening out there. The Iowa DOT has been very valuable to us.
The goal of the Department of Transportation is to get travelers to their location efficiently and safely. We have operators continuously looking at over 400 cameras and other data sources 24 hours a day, 7 days a week. It's very difficult to analyze all the different information coming in.
We're hoping to condense that data flow and be able to analyze it much more quickly with help from Iowa State.
We're really excited to use machine learning to address the operations of the road. TensorFlow is helping us understand the traffic patterns, and with that information, we can be better in alerting and being predictive.
Machine learning can automatically check those images from the camera to detect if a crash happens, and we can send the information to traffic engineers.
And if there's going to be something that's going to impact your commute, we want to get them that information as soon as possible.
If technology could help us determine what's occurring across the entire school district, we'd make better decisions for our kids. We wouldn't be up at 5 o'clock in the morning driving the roads. I would sleep in, to be honest with you.
Machine learning has really revolutionized the way we think about the data we have, the connection we have to vehicles.
The Iowa roadways are safer because of all the technology we've been able to bring. We're making travel more safe and efficient, and so I only see that getting better.
All right, so this is how Iowa State is actually using all the data that they're getting from whether it's the video feeds or the different traffic data that they're getting. They are actually able to predict the accidents. They are able to predict where the potholes are, and they're leveraging all of that data both in the planning and operations management. The next example I'm going to talk about is the city of Memphis. They were struggling to maintain visibility of the potholes and vacant properties which has been abandoned. And historically, they relied on resident reporting. However, these reports only covered about 20% of the problems, often the worst case ones. So recognizing the need to address the problem, they began to look for ways to apply technology to better reduce potholes and hold homeowners accountable for these abandoned properties. The city of Memphis worked with the Google Cloud team to build a solution to detect these potholes and abandoned properties by analyzing the video footage of the roads and residential property using the cameras that was fitted on their public buses. The solution was built using a ML service of GCP and primarily using the AI platform Deep Learning VM Images. On the detection of these potholes, the solution automatically raised a ticket in their existing grievance redressal system to alert the maintenance staff to repair those potholes. So apart from the video feeds, the city also imported routes, potholes data, paving data, and geolocation data into the systems to better understand the street conditions and the proximity of the potholes to one another. The solution really helped the citizen with faster detection of and repair of the potholes and these abandoned properties, resulting in a better citizen service and experience to the citizens. So again, this is a great example of using their existing assets and data to build intelligent systems that help to improve the overall process. Some examples from India. We are working with Pune Transport Department, PMPML, to enable real-time tracking of public buses on Google Maps. This will help to improve the commuter's experience as they would be able to plan their trips much better by reducing the wait time for buses at the bus stops. This data can further be used for other use cases. That could be a predictive maintenance of the buses. It could be for better route planning, which is data-driven, and it would actually help to reduce the overall cost and improve the commuter's experience. Apart from this, we are also working with the Bengaluru Traffic Police to help improve road safety and reduce traffic congestions. Google Maps will show live road closures and will also suggest alternative roads that can be navigated to reach the destination using the data that is being provided by the Bengaluru Traffic Police. The pilot phase result showed about 20% reduction already in the waiting time for commuters and motorists at the road intersection for the scope of the pilot. So these are just a few examples, some idea creators. And when you think about it, we are looking across all of these different areas. Data and analytics can be applied to any one of these areas to bring in new insights, to be able to operate in new ways. So our rule as Google, the way we think about is that we are really democratizing, just give me 1 second, the science and technology. So we know it is hard for the government departments, transport department, to hire a lot of data engineers or data scientists. And so what we are taking is a lot of complexity out of this technology and making it more accessible so that the business users and even the non-technical people can take advantage of the technology and use it to deliver insights and make decisions that are faster, easier, and more accessible to many more people within the department. And we are keen to work with you and your teams to really support your team in using your data to generate insights using AI/ML, or to solve your key challenges within transportation, or for that matter, any other sector. So thank you so much. I hope I was able to create some ideas going on in your mind of how could you leverage your existing data and leverage that to create insights, both in your operations and also for planning when it comes to transportation, solving some of the challenges that we talked about. So thank you once again, Economic Times, the Rajasthan government, and other partners for having us here. Thank you.